would be the number of electrons. So here we go, 3. So now we need the number of electrons and electron shells / orbitals. Now remember, orbitals are equivalent in language. I don't like the word orbital, but that's okay. So what do we know? So electric charge comes in 2 flavors. One, there's proton charges. And what we call proton charges, we call it a +1. And that's the reason why I call that P+. And when I look at electron charges, we find that this is -1. And that's why for the electron, I write a minus. Now, nature truly has very few particles that are absolutely neutral. Light is neutral. There's these things that are called neutrinos that are neutral. There's some other things that are neutral, but it's extremely, extremely rare. So when we talk about neutral things, like we'll say the neutron charge, we do say is 0, and that's why I write that. But let me expand on the neutron a little bit. What we find here is that the amount of charge inside the neutron has equal amounts of positive and negative charges. So when you look inside the nucleus here, you look inside the neutron, it does have positive charges and it does have negative. So most things in nature that are neutral is because they have equal amounts of positive and negative charges. So, and remember what I said, it is really, really rare when you get, objects that are literally chargeless. Very, very rare. Okay, let's keep going. So now we could then write what we want to say here. And this is what we'll say here. All atoms on the periodic table are electrically neutral. So this immediately tells us what? So when I say electrically neutral, look what I said over here. Equal amounts of positive and negative charges. So this means here that we must have, so the number of protons must equal the number of electrons. That's how most things are neutral. So now we could then go back in And let's look at oxygen, for example. If I look at oxygen, we could then come in and go like, okay, here's oxygen. If I look at oxygen, if I write this in atomic spectra, what did we say? Well, oxygen has what? It has 16 and it has 8 protons. So if this is oxygen, now if I subtract them, I could immediately come in here and say, okay, I have what? 8 neutrons. I have 8 protons, but now I know that I have 8 electrons too, because those numbers are exactly the same. So picture-wise, just to be complete, here's my nucleus. So that means I have what? 8 neutrons, 8 protons. So then electrons do not live inside the nucleus. So what we find here is that we have 8 electrons outside the nucleus. We don't know where they live. So that brings us to the next piece here. And what we say here is that we say this here. We say, we go in here and then I'm going to ask a question. Where do the electrons live? And this is what we call electronic shells outside the nucleus. Electrons cannot live inside the nucleus. So how do we do this? And it goes like this. So it turns out that the number of electron shells we just say electron shells, is equal to the row number on the periodic table. Okay, so let's go do this. So I just did oxygen. How about if I go and I grab chlorine this time? So let's look at chlorine. So I need to go get the first 3 rows on the periodic table. Okay, so I hope this isn't too big. It might be too big. Let's see. Yep, it's too big. So if you look at this thing, let's look at this guy. So the first thing that we want to do here is that I come in and what do I do here? I immediately look for the element number 17. So when I go to the periodic table, look at this is element 17. So if I count the number of rows, this is row number 1, row number 2, row number 3. We see that chlorine is in the 3rd row. So what does that mean here? Well, it means this. So if I look at chlorine, we could see here that we had 35 protons and neutrons, the atomic mass. We have 17. And now I have chlorine. So what am I going to do? I'm going to subtract these. So if I subtract these, what do I see here? 1, we already know that we have 18 neutrons. We have 17 protons. And we have 17 electrons. But now what we said here is that chlorine is in the third row, which means it has 3 shells. So this is not quantum mechanics that I'm drawing. I'm actually drawing this image. This is what's known as the Bohr model. So this is what's called the Bohr model of shells. And this is all we care about. We don't care about the quantum mechanical model because it's way more complicated than this. But here's what we see here. Well, what do I know about the nucleus of chlorine? The nucleus of chlorine has what? We see that it has 18 neutrons, 17 protons. And so what the Bohr model says, that they go like this. I have 1, 2, 3 shells. Now, I will never, ever ask you to do this because it gets complicated very quickly. Okay? So remember, I will never ask you to do this, but check this out. If you look at chlorine, note that there's these 3 numbers right here, 2, 8, and 7. So what does this mean? The electrons live where? Well, the 2, because it's at the first one, means that there are 2 electrons on this shell. And then when you look at the second shell, it has 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. And then on the third shell, it has 7. So then I go 1, 2, 3, 4, 5, 6, 7. So if I come in here, this will be 2, 8, 7. In other words, we see that 17 electrons live in 3 shells. But remember, this is not a good model of the atom. The Bohr model definitely is not a quantum mechanical model. It's what is known as a semi-classical. So to start from something completely different, let me go draw another one, see if we have enough time to actually do this. So let's do nickel. So we did nickel earlier, but this time my shells have to increase. And again, this is going to be too big. And I'm going to have to reduce the size on this guy. So let's see if I can do that. Okay, that should do it right there. So let's go look at chlorine. Oh, excuse me, not chlorine, nickel. Let's look at nickel. So here we go. What do I focus on? I focus on 28. I look for atom 28. So when I come over here, this is the atom. So let's calculate this thing very quickly here. So I got nickel. And if I look at that, the total number is going to be 59. This guy's going to be 28. So let's subtract this and get the structure here. So then if I subtract these guys, I'm going to get what? 31 neutrons. I have 28 protons. I have 28 electrons. And you could see that this guy lives in what? The 4th row. So that tells me then that, right? We say that this is on the 4th row, which means that now it has 4 shells. So here we go. How would I draw my atom in this class? I'd go, I got 1, 2, 3, 4. I go 1, 2, 3, 4. And then I look at this thing and I go, okay, I have 31 neutrons. I have 28 protons. And now, how do I label this? This is 28 electrons live in these 4 shells. Note, I did not try to organize this thing. So when you go and you look at these guys right here, these actually get more complicated. And it turns out that these shells look different here.